Hey guys, this is Sergey. Asynchronous programming is one of the most essential aspects of modern .NET applications, and a solid understanding of async methods is incredibly valuable. Most resources explaining async internals rely on decompiled code and vague explanations, but we can do better. Today, we'll dive into the compiler-generated code and we'll use the debugger to step through .NET internals, seeing with our own eyes how async methods really work under the hood. If you enjoy this kind of deep dive content, please like and subscribe. It helps the channel a lot. To debug async methods, we're going to use a few tools. First is the IL Viewer. The IL Viewer is a resharper plugin that allows us to see the compiler-generated code. The next one is going to be the debugger itself. Another tool that is very useful for such kind of investigations is parallel stacks. Another thing that you need to check to debug .NET code is that all the symbols are loaded properly for .NET itself. One thing to do that is to open modules and then to make sure that system private core DLL symbols are loaded. You can right click here and check that always load automatically symbol is set. Then you need to also check the symbol settings and to make sure that NuGet.org symbol server is enabled. You also need to uncheck Enable Just My Code in Tools options. Now let's look at the async method that we are going to debug today. This is a simple process async method that traces some stuff on the console, then calls another async method. I've intentionally split the call to get data async with the awaiting of the task, and then we are printing the results. Let's look at the IL Viewer first. As you probably know, async methods are drastically transformed by the compiler. The only thing that is happening here is that we're using async task method builder to create it, and then we call start on it, and then we return the task. The main logic resides in this moveNext method, which is a state machine that is broken into pieces based on the number of awaits. To start debugging this thing, we can find async task method builder class and find its start method. So here how it looks like. So the start method just calls the start method on async method builder core. We can go there and we can see that the only thing that is happening here is capturing some execution context, and then we call moveNext on the generated state machine. So let's go here. So we are calling this method, and if we look at parallel stacks, we can see that indeed we are calling our process async method. We hit here, so the debugger cannot show the actual source location because it's hidden from us. And we already can see that the start of the method is called from the same thread. So we can see that we're able to call moveNext, and here the code that corresponds to our moveNext logic. So the start method just calls moveNext, and this is how the async method starts. And again, we can see that we are running this code from the caller thread. And it means that if this block of code will take a lot of time, we will block the running thread. This code is not executed asynchronously. So let's go further. Now we got the task. I've intentionally decided not to use async await to simplify things a bit. So we got the task, and we can use make object ID because we are going to track how the runtime links this task to our continuation. So we're back here into moveNext method. The logic here is the following. So we're going to get the awaiter from this task, and we will check if the task is completed, we will just move forward. But if the task is not completed, we're going to use our builder and call await unsafe onCompleted method. And again, we can put a breakpoint here, we can hit F5, and we will get here. We can collapse IL Viewer because we are not going to rely on it for some time. And now we can go deeper into this code. The runtime creates a wrapper around the state machine. The state machine itself might be a struct or a class. So this box represents our state machine, and essentially it represents the process async method. And await represents the task that we're waiting for. We created an object ID of it, and we can see that this is the same instance that was created by task.run. And so essentially what this method does, it links the awaiter with the state machine. Let's look further. So we have this output wait ETW event helper that we can ignore, but the idea is that task is our task that we're waiting for, and moveNext is the delegate that we will use to move the state machine forward. And now we're inside task.cs. We will ignore continue on captured context for this episode, and we'll cover it in more details later. So the main thing that this logic does is that we're adding a continuation, our wrapper that was just created recently that wraps the moveNext for our state machine logic with the current task instance. It means that when this task is completed, we can register a bunch of continuations manually with continue with methods or explicitly by awaiting the task. And right now we are linking this task together. And once we link the continuation of our task with our state machine, the job of the main thread is done. So if this is a main thread, it will be blocked. If this is a thread from the thread pool, it can be reused for other purposes. And now we can run the code again to wait for this long-running task to finish and see what's going to happen in that case. And now our async operation is finished, and let's see what's going to happen in this case. First, we will remove this from active running task that is used for the debugger only. Then we'll change the state to completed. And now we can see that the status of the task is ran to completion with result 42, and it's typed to run all the continuations. We can check that our continuation object is our wrapper class that eventually represents our moveNext method of our async method. And now we're calling this continuation. And as you can see, we ended up in our process async method again. We can get back to our IL viewer, and now we're executing this piece of code that corresponds to this block of code in that generated state machine. And once this block of code completes, we will set the result of the task builder and our asynchronous operation will be finished. Now it's time to get everything together to better understand how async methods work under the hood. The first thing to remember is that the async method itself is translated into a state machine. And the method itself is just creates a sync method builder, and then it calls the start method to move the state machine forward. And the state machine itself has multiple states, each of them represents the block of code between the awaits. In this case we have a single await, so it has two states. The first state is used when async method builder calls moveNext for the first time. And in this case, this block of code that start and get data async is called from the same main thread that initiated the async operation. Then it calls getDataAsync. GetDataAsync initiates the asynchronous operation in the background, or however that async method is implemented. Once getDataAsync returns a task, we use async task method builder again to link the task with the state machine. So we call await unsafe on completion by passing task awaiter and the state machine. The main thing that is happening here is that we are linking together the task itself with async state machine. So when the task completes, it runs all the continuations, and one of them is going to be our moveNext method in our generated state machine. So let's move further. At some point, asynchronous operation completes. It calls continuation wrapper that calls moveNext in our generated state machine. And now this code is executed either in a worker thread or in IO completion port thread. It depends on how the task is actually implemented. And our state machine just gets the result from a task awaiter and prints the results. And because there is no more awaits in the state machine, the operation is essentially done. Worker thread is free and the whole operation is completed. I had two goals for this video. First, I wanted to demystify async methods, showing that there is no magic behind them. By looking into the compiler-generated code and debugging.net internals, we can build a complete and accurate mental model. Second, I wanted to demonstrate that debugging.net internals is just like debugging your own code. Don't be afraid to look under the hood of things you're dealing with, and debugging is one of the best ways to learn the internals. Today, we check the async machinery, but you can apply this approach to other .NET concepts as well. Next time, we'll continue the journey by diving into how configure works under the hood and whether you should always use it. If you enjoyed this video, hit that like button, subscribe, and let me know in the comments below what .NET topic you want me to cover next. That's it for today, guys. Thanks for watching, be curious, and see you next time.